Hey people, welcome back. In this session, we are going to learn about how do we compare the variance or standard deviation of two samples with each other. We will be learning about two variance tests. So two variance tests mainly we do either we are comparing the variances of a data set or maybe the standard deviation of the data set too. Suppose I have an example. If I take here is the data from the process A and you have a process B. How much is the variation between these two process data set you want to compare? Let's say process A, your current handling time or average handling time maybe is ranging somewhere from 20 minutes to 30 minutes per transaction. Where the second data set, the process you are comparing with respect to the variances, maybe is ranging from let's say 10 minutes to about maybe 18 minutes. Just for example. And these two data set, you have the process variation collected for last, assuming let's say 30 sample, which is 15 sample each you have collected, right? So based on these 15 sample for the process A and process B, which you have collected, you wanted to compare the variances or the standard deviation of these two process. Then how do we perform, which test we perform? So there is a prerequisite before we perform the two variance test or two standard deviation test that you should understand the data distribution, either it's a normal or it's a non-normal data. So when you have the two data set and you wanted to compare with it's normally distributed, then we will be comparing the variances with the help of F-test. And if data is not normal, we will be using the Levene's test. These are the two tests we perform. So before we perform variances, we must know data is normally distributed or not normally distributed. And we all know for the normal distribution, to understand the data is normally or not normally, we perform the Anderson-Darling test. This is the situation when we perform this. So how to do this? Let me just copy and paste these two data set in the mini tab. Assuming here is your these two data set from where I pick up process A and process B, and this is my data. I wanted to find out data is normal or not normal. So I'll go to graph. I'll click on probability plot. I do select single. Select your both of variables, process A and process B. In multiple graphs, select separate panel of the same graph and you click OK. Now you have the result of Anderson-Darling statistics, which is based on this distribution. So you can see clearly that my one data first p-value is less than 0.05. It is 0.033 and the another p-value is 0.136. So this data, because p-value is less than 0.05, it's a not normal. And this data is p-value greater than 0.05, it's a normal. So whenever such situation will come when the one data set is normal and the another data set is not normal, so we treat our entire data set as a not normal. Though I will be explaining you both how to perform the F-test and the Levene's test for the variances. So, or ideally, I should treat my data as a not normal. We can see the average value of the first data set is 25.4 with a standard deviation of 3.09. And average value of the second data set is 13.13 with a standard deviation of 2.58. So 3.01 or 2.58 standard deviation seems that they are same. I'm expecting the variances will be equal, but still we will perform this analysis. So how to do normality assessment we have done. Now to perform the two variance test, I need to go to the stat, basic statistics, and here I will be selecting the two variance test. Because my data is not normal, so what I will be doing, I have to give the instruction to Minitab that my data is not normally distributed. So for that, I'll go to the option. In option, you have a column, use test confidence interval based on normal distribution. So if I will check this box, this will assume my data is normal. If I don't check this box, this will assume my data is not normal. If I don't check, I will get the p-value of Levene's test. And if I check this, I will get the p-value of F-test. Because my data is not normal, let's do assume the data is not normal. So I will leave this box unchecked here. Just leave it as it is, click on OK and click on OK. And now we will be reading the hypothesis. So what hypothesis says? You can see the p-value of Levene's test is 0.404, which clearly said data distribution or the variances are same. They are not different for the process A and process B, both are same. This what p-value will be reading for the Levene's test. And if I assume that my data is normally distributed, so what I will do, when I'll go back here in the stat, then basic statistics, and here is the variances to variance test, and in options, you check this box, used test and confidence interval based on normal distribution. If I check this box and then I see the result, I will get the p-value of F test. Now you can see the p-value of F test is given here, 0.572. Where 0.572 is a null hypothesis. Null will say there is no difference. So we can clearly state here that our hypothesis was that we are trying to understand either the variances are same or different. And when I look at this, either with the F test, which is for the normal distribution, or Levene's test, which is for not normal distribution, in both the case, I got my p-value greater than 0.05 at 95% confidence level. So I can conclude that the variances among these two data set, process A and process B, are statistically same. They are not different from each other. That's how we'll be concluding this. Thank you so much, you people, and I'll see you in the next session.